We're going to talk about hypothesis testing and actually finding p-values and conducting a full hypothesis test. So what is a p-value? Again, a p-value is assuming that the null is true, the probability that the test statistic would have a value as extreme or more than what is actually observed. So in other words, is it far out in the tails? So that's what the p-values are going to tell us. Is it closer to the middle, what we should expect, or is it out in the tails? So level of significance is the amount of evidence necessary before we begin to doubt that the null is true. It is the probability that we will reject the null, assuming that it is true. And it is denoted by alpha. And it can be any value, but for AP statistics purposes, it's usually either a 0.1, 0.05, or 0.01. And most common is 0.05, and use this one if it's not stated otherwise. So if no alpha is given, use 0.05. Statistically significant, the p-value is as small or smaller than the level of significance alpha. Thus, if p is greater than alpha, we fail to reject the null hypothesis at the alpha level. And if p is less than or equal to alpha, we reject the null hypothesis at the alpha level. So I have a little saying to help you remember. If p is low, reject HO. So remember, p is low, reject HO. So facts about p-values: always make decision about the null hypothesis. Large p-values show support for the null hypothesis, but never that it is true. And small p-values show support that the null is not true. And for two-tail test, if you're doing a not equal test, you need to double the p-values. Now, if you're utilizing calculator to find p-values, which I'll show you how to do here in a minute, the calculator will automatically double it for a two-tail because you have to input in that you are doing a two-tail. But if you're doing calculations by hand, I need to double the p-value. I cannot say this enough. We never accept the null. You either reject or you fail to reject. Maybe we just don't have enough evidence yet to state. So never accept the null, never accept the null, never, never, never accept the null. Reject or fail to reject. So at an alpha level of 0.05, would we reject or fail to reject for the given p-values? So if our p-value is 0.03, again, remember if p is low, reject HO, so we would reject here. 0.03 is less than 0.05. 0.15 is greater than 0.05, so we fail to reject. 0.45 is greater than 0.05, so we fail to reject. And 0.023 is less than 0.05, so if p is low, reject HO. So how do we write our conclusion statements? It is a statement of the decision being made, either we reject or we fail, and linkage. And we also need to relate it in context of terms of HA. So what is the sentence stem that you need to memorize to fully conclude your hypothesis test? Since the p-value less than alpha, I reject HO. There is sufficient evidence to suggest HA. Or since the p-value is greater than alpha, I fail to reject HO. There is not sufficient evidence to suggest HA. And HA will always be put it in terms context of the problem, which typically is the very last sentence question that it's asking. So just like with confidence intervals, use the wording of the problem. So let's look at an example. Drinking water is considered unsafe if the mean concentration of lead is greater than 15 parts per billion. And suppose a community randomly selects 25 water samples and computes a test statistic of 2.1. So assume the lead concentrations are normally distributed. We need to write the hypothesis, calculate the p-value, and write the appropriate conclusion based on alpha 0.05. So they've done a little bit of work for us already. They give us the test statistic already, so we don't have to calculate that. But let's start with the hypothesis statement. Again, we are going to assume true that mu equals 15. We are thinking that mu is greater than 15. And we're going to define our variable. Mu is the true mean concentration of lead in drinking water. So again, you don't have to calculate this test statistic here. It tells you t equals 2.1, so you can look at your t table here. And again, we're looking for probability of area to the right because this is great. We're testing against greater than 15. So if you do 1 minus the value in the t table, you should get a p-value of 0.0232. So your p-values can be found by either the z or the t table. Here in a minute, I'm going to show you how you can utilize the calculator for a faster route. But based on p-value of 0.02, if p is low, reject HO. So 0.02 is less than 0.05. So therefore, since p is less than alpha, I reject HO. There is sufficient evidence to suggest that the mean concentration of lead in drinking water is greater than 15. So again, if you're ever worried about how to conclude this sentence, use the wording in the problem. And again, we didn't have assumptions here, but notice assumptions would be SRS. It does state the word random. Notice it does state that it is normally distributed. And then here we already know it said a t-test, so obviously sigma is unknown. But we should have those assumptions as well. So formulas, so that one did a little bit of the work because you did not have to calculate the z or the t-test statistic. The formula, when sigma is known, is we would be doing a hypothesis z-test. Test statistic, as always, is the same. Your statistic minus your parameter divided by your standard deviation. Again, written in easier formula terms would be your x bar minus your mean divided by your standard deviation divided by square root of your sample size. Again, this is a formula on your formula sheet, so make sure that you are able to locate it there. If sigma is unknown, we would call it a hypothesis t-test. Again, same procedure, except that we don't know our population standard deviation. So we're doing x bar minus mu divided by s, your sample standard deviation divided by square root of n. Or we could use the calculator. Okay, so again, if you like to use the formula, you can. You'll have to calculate the test statistic. You'll have to look inside the z or the t table to find your p-value. You are more than happy to do that. If you want to use the calculator, you can go to menu, statistics, test, and then either do z or t based on whether sigma, your population standard deviation, is known or not unknown. And here's how you got to show your work for all problems, okay? You got to start with your assumptions. SRS, is it normal? State how is it normal? Stated, is it a symmetrical box plot or histogram? Or are we using n greater than 30 sample size? You need to write your null alternative and define your variables. You need to state, is it a one sample z or t test if you're using calculator? And then just like with confidence intervals, you got to put everything the calculator asks for. Everything you enter in, you need to write that out. And then as your output, you need to make sure to write what your z statistic is, either from calculator output or from your hand calculation, what your alpha is. Again, use 0.05 if it's not stated. And you need to write your p-value, whether you use the z-t tables or you write it from the calculator output. And you're not done until you make that final conclusion statement. Okay, so statistics is I call it a half English class. So make sure that you have all of these parts for full credit. Let's look at an example. A certain type of frozen dinner states that the dinner contains 240 calories, and a random sample of 12 of these frozen dinners was selected from production to see if the caloric content was greater than stated on the box. The t-test statistic was calculated to be 1.9. So assume calories vary normally. Write the hypothesis, calculate the p-value, and write the appropriate conclusion, all for an alpha of 0.05. Okay, so start with our null. Again, actually, we start with assumptions. It says that it's normal. It says that it's random. And it already tells us the t-statistic, so sigma is unknown. So our null would be that we're assuming true, our mu equals 240 calories. We're testing to see if our mu is greater than 240. And what does mu represent? The true mean caloric content of the frozen dinners. Based on our, it gives us the t-statistics. You don't need to calculate that, but you do need to look at your t-table. And since we're testing against greater than, you need to do 1 minus the probability inside the table. After you do 1 minus, you should get a p-value of 0.0420. So how do we write our conclusion statement? If p is low, reject HO. 0.04 is less than 0.05. So since p is less than alpha, I reject HO. There is sufficient evidence to suggest that the true mean caloric content of these frozen dinners is your alternative greater than 240. So let's look at another example. Here we have Fritz Cheese. Fritz Cheese Company buys milk from several suppliers as the essential raw material for its cheese. Fritzy suspects that some producers are adding water to the milk to increase their profits. Excess water can be detected by determining the freezing point of milk. And the freezing temperature of natural milk varies normally with a mean of negative 0.545 and a standard deviation of 0.008. Added water raises the freezing temp toward 0 and the freezing point of water in Celsius. Laboratory manager measures the freezing temperature of 5 randomly selected lots of milk from one producer with a mean of negative 0.538 degrees. So, is there sufficient evidence to suggest that this producer is adding water to his milk? So we got to start with assumptions. So what are our assumptions? Does it have the word SRS? It says I have an SRS from milk from one producer, so that is check. Do we know, is it normal? It says is given a normal distribution, so normal given, check. Do we know our population standard deviation? And population standard deviation is known. It says from the population of, or we have a sigma. So we can proceed, since sigma is known, with a hypothesis Z test. So to start proceeding, we need to state our statements. So we are first going to assume our null is going to be that our mu equals what they say, negative 0.545, but we are assuming that that water level is greater, so mu is greater than negative 0.545. So where mu is the true mean freezing temperature of milk. Again, don't forget to label your variable. So again, you could use the calculator. Again, go to menu statistics. Stat test. And again, you would do a Z test. Again, if you have data, if you actually have the data values, you'll use data. More often, you're going to right arrow and go to stats. And again, put in your mu, put in your sigma, put in your X bar, and put in your N. Or you could plug in formulas. So again, if you're calculating z by hand, this would be the formula, x bar minus mean divided by standard deviation divided by square root of n. Or you're going to label hypothesis z-test. Your mu is negative 0.545, sigma is 0.008, x bar equals negative 0.538, and n equals 5. So that is just like confidence intervals. That's how you need to state your showing work for a calculator. After you hit enter and calculate, you must state alpha, you must state the p-value. Okay, so the p-value you can get from the calculator. If you're using the z-statistic, you need to go inside the z-table. But our p-value from calculator output or z-table should be 0.0252. So we compare that to alpha. So is p low or is p high? Well, p is low, so conclusion statement. Since p is less than alpha, I reject the null. There is sufficient evidence to suggest that, what are we talking about? True mean freezing temp is, what is our alternative? Greater than negative 0.545. So again, this suggests that the producer is adding water to the milk. Again, you don't even really need that last sentence. All you need is that final conclusion statement. So we can never say that we accept. We can never say that somebody's telling the truth or not. We either reject or we fail to reject. So let's look at another example here. We have the degree of reading power is a test of the reading ability of children. And here we have a variety of scores for a random sample of 44 third graders. And this is in a suburban district. So at the alpha equals 0.1, is there sufficient evidence to suggest that this district's third graders' reading ability is different than the national mean? So to start, we need to state our assumptions. Do I have a SRS? It says random, so yes, check. Do we have normal? Well, based on sample size, we could say n is greater than 30, right, with 44, so it would be approximately normal. If you also wanted to do a histogram, you could, but rule of 30, n greater than 30, yes, proves normal. Do we know sigma? Well, if we only have a set of data, that answer is always no, so sigma is unknown. Okay, so this would be a t-test, not a z-test. And what are your hypothesis statements? Our null hypothesis would be that mu equals 34. That mu, we're testing it against that it just does not equal 34. We don't know greater than or less than. And mu is the true mean reading ability of the district's third graders. So next we need to proceed with the test. So I'm going to show you how to utilize the calculator, as this one would be quite difficult to do calculating by hand. Okay, so if we pull up our calculator, since we have a list of values, first thing is you need to label your title. Again, label it whatever you want, X, Y. Here we have DRP, doesn't matter. Again, type in your data values. So here we have Here we have 44, so biggest mistake made is not inputting all your values. So double check at the end to make sure that you've actually input all 44 data values. I would double check twice. So kind of like when they say about cutting wood, you measure twice before you cut. Okay, so again, I had 44 values. I ended on 44. I'm good. So to conduct your test, again, you're going to go to menu if you have a TI Inspire, statistics, stat test, and you're going to go to t-test because again, every time you enter data, you do not have population standard deviation. So I have it from data. So remember, data is if you're using the list in spreadsheets, stats is if you actually have a mean, standard deviation, so forth. So we're going to do from data. It needs to know what my mu is. Here we set our mu, we're testing it against 34, right? What list am I using? I called mine DRP. Again, you can click the arrow and find whichever one you need it to be. Again, alternative, we're testing against not equal to. So notice it just says is different. I don't know if it's greater than or less than. So we're using not equal to anytime it says is different. And click enter, go up from your output. So notice here, you need to write down your t-statistic and you need to write down your p-value. Your p-value is 0.52. And notice for a t-test, it gives you your degrees if you know as well. So make sure to put all your output here as you're showing work for calculator. So again, we wrote our statements. We're testing against not equal to. Again, you can either hand calculate the t-statistic and use your t-table to find the p-value. Or again, you can use what I just said, the calculator, where you write out hypothesis, t-test, and everything the calculator asks for. Mean equal, you're testing mu equals 34, mean equals 35, sample mean equals 35.01, and your little s is 11.189, etc. But whichever way you do it, if you do it by hand, if you're using the formula sheet to calculate the p-value, remember that the p-value you'll get is going to be 0.26, but since this is a two-tail, a not equal to, you have to double that. Now notice if you did the calculator output, calculator automatically knows that it's a two-test and will double it for you. But p-value is 0.52. If you're doing it by hand, you have to manually double it, okay? But p-value is 0.52, so, and we're comparing against alpha 0.1. So what does that mean? Since p is greater than alpha, I fail to reject the null. There is not sufficient evidence to suggest that the true mean reading ability of the district's third graders is different than the national mean of 34. So let's look at another example. We have a Wall Street Journal reported that based on sales in a chain of Midwestern grocery stores, President's Choice chocolate chip cookies were selling at a mean rate of $13.23 per week. So suppose a random sample of 30 weeks in 1995 is the same stores show that the cookies were selling at the average rate of $12.08 with a standard deviation of 275. Does this indicate that the sales of the cookies is different from the earlier figure? So we're talking about cookie sales here. So again, we start with assumptions. Do we have an SRS? And yes, it's stated SRS. Is it normal? We have a large sample size. Our sample size is 30. So due to n being greater than 30, yes, it is normal. And little s is unknown. So alternative, we first assume that they're true. Mu, what they're making, weekly sales is 1323. And we're assuming that it is not, because notice the wording in the problem. Does this indicate that it is different? If it is different, means it's not equal to. And we define mu. Mu is the true mean cookie sales per week. So again, you can either calculate t-statistic by hand, or we can utilize the calculator by showing appropriate work, hypothesis t-test, and state sample mean 1208, population mean 1323, sample standard deviation 275, and n equals 30. Write it out. Either way, you should get your p-value at 0.0295. Again, calculator will directly give it to you. If you're using the t-table, you have to double that for the two-tail test here. But let's compare p to alpha. Since p is low, reject HO. So since p is less than alpha, I reject the null, which means there is sufficient evidence to suggest that the sales of the cookies are different from the earlier figure. Okay, so can't stress this enough. Make sure to use that very ending, typically it's the last sentence wording, in your conclusion statement. So we have the same statistics here, and it's asking us to compute a 95% confidence interval. So I'm going to show you the difference between how a hypothesis test is just a different way of doing a confidence interval. So if we compute a 95% confidence interval for the mean, again, you can utilize your calculator, menu, statistics, confidence interval, t-interval. We will get 1,105.30 and 1,310.70. So based on this interval, okay, if it's asking us, it has a mean rate of 1323. Is it different from 1323? Well, it's 13, again, since 1323 is outside the interval, we reject HO. There is sufficient evidence to suggest that the mean weekly rate is different from 1323. Okay, so again, a hypothesis test is a more direct way of conducting this confidence interval check. Again, in the last chapter, we would have to make an interval and then see if it's inside or outside. Hypothesis test is a more direct route for that, but notice we get the same answer. So what do we notice about the decision from this last answer? What decision would you make on this example if alpha was 0.01? Well, if we look at the p-value on the previous one, which was from the previous side, 0.0295, we would fail to reject because 0.025 is greater than alpha, so we would fail to reject. So this is why alpha level is important. Your decision could change based on your confidence level. What confidence level would be correct to use? Well, we should use a 99% confidence level for a two-sided test. Because again, you have 0.01 in each of the tails. So does that confidence interval provide the same decision? Well, if this is our interval, since 1323 this time would be in the interval, we would fail to reject. Okay, so again, if you change your confidence level, it definitely will change your interval. Make sure to redo the test and change your conclusion statement if needed. So what if our alternative, that mu is less than 1323, what decision would the hypothesis give at alpha equals 0.02? So now what confidence level is appropriate for this hypothesis test? Again, if your p-value is 0.01475 at alpha 0.2, then we would reject. Okay, so p is low, reject HO. So if we're doing the 98% confidence interval, we'd get 1,084 to 1,331. And since 1323 is in the interval, we would fail to reject. Again, why are we getting different answers? In a one-sided test, all of our alpha goes into the tail, goes into one tail, and it's two. But the tails have equal errors, so there should also be 2% in the upper tail. So that leaves 96% in the middle, and that should be your confidence level. So a 96% confidence interval would provide 1323 would not be in the interval, so we would reject. So again, confidence level, whether you're doing a one tail or a two tail, very important to check the values. And tail probabilities between the significance level and the confidence level must match. And that concludes a hypothesis test.